Okay, AV and Safia, the checkpoint test is for you to do at home because you were not here last week. Pritika already did hers last week already. So you have to do at home, then next week I will collect from you, then we'll go through the answers. Okay? So for today, we are doing diversity of materials. The notes, the coach will pass to you later, lah. All right? So we go to the front first so we can recap what we have done so that the rest will not be as lost, lah. Okay? So, diversity of materials. Before this, we learned about the diversity of living things, right? So, diversity basically means different types. Okay, so there are many different types of materials around us. Uh, Basically, we must choose the correct material to make different things so that they basically are safe, lah. Most of the time when we choose something, it is to make sure that we are safe while we are using it. All right, whether it's a chair, a table, a food container. Okay, so there are different things around us in the world. Some things are safe for us to use. There are other things which are dangerous, but which we use it for other things, lah. Okay, so there are different materials. They have different purposes. They have different properties, meaning each one of them are chosen for a certain property that they possess. Okay, that's why we make our chairs out of metal or plastic. So first of all, we choose things based on whether they are safe. Second things, we choose things based on whether they basically the price of it. Okay, there's nothing stopping us from making a chair out of wood. In fact, if you look at in the past, most chairs made of wood. But why don't we use wood today? Why are the chairs that you're sitting on made of plastic? That's because plastic is cheaper than wood. Okay, so safety, we also look at the price. We also look at how easy it is to make it into something. So for wood, there's no way for us to melt wood and then turn it into something that we need. Wood cannot melt. In fact, if you were to heat wood, it will just burn. It will turn black. Alright? You can cut it, but cutting is more difficult than to form it in a mold. So for example, that's why your chairs are made of plastic. Plastic can melt, and then it can be formed into a mold. So what are the different types of materials around us? There are different types of materials. For example, wood. Wood was one of the first materials human beings decided to use to make different things around us. So in the past, furniture is made out of wood. That's why if you have a dining table at home, most probably it's made of wood. Okay, chairs also, they are also made of wood. Some of you, your bed frames are made of wood. Some of you, your kitchen cabinets are made of wood. So wood was one of the very first materials that human beings discovered could be used to make other things. That is why you see a lot of things are made of wood. In the past, even homes were made of wood. The walls, the floors were all made of wood. Okay, but as we progress through history, we discover there are other things that we can use to make the things that we need. Therefore, we use less and less of wood. Now, wood, for example, here in this picture, comes from, where does wood come from? Trees, right? Wood basically comes from trees. So for us to get the wood, we must cut down the tree. What happens when we cut down the tree? Is the tree still alive? No. The moment you cut down a tree, such as this, the tree dies. Okay? So what must we do whenever we cut down a tree? Well, basically companies, every time they cut down trees, they will plant new trees. But trees don't grow like that, right? In fact, these tree trunks here that you see would have grown for at least 10 years. So you must actually wait 10 years for new trees to grow before you can cut them down again. So it's a very long time. So that's why wood, nowadays, not many things are made of wood. right? Chairs nowadays, most houses are moving towards metal or plastic chairs. Okay, even in school, if you look at your school, your classroom, your chairs are made of plastic. The backing lah. Okay, the legs are still made of metal. All right. In your canteen, your tables are no longer made of wood, they're made of plastic and metal. Okay. But the one thing that we still use a lot of wood for is actually paper. So whether it's colored paper, non-colored paper, all paper is made from wood. You all know how paper is made into wood? Wood is made into paper. Okay, there's a short description here of the process of making paper. We basically cut the trees into small pieces like that. That is called wood pulp. Okay, then we add acid, chemicals, and water to soften the pulp. Once the pulp has softened already, okay, it will be like that, the white color piece there. So basically, the white color piece is one sheet of paper lah. All right, we press it down so that the wood fibers will join together, and then we make it very thin so it will actually become paper. Once that's done, we will dry it and then we cut it into whatever shape we want. If we want colored paper, we'll add dyes into it, basically colored liquids into it to make different colored paper. Okay. Um, in the past, you could go to the zoo to learn how to make paper, right? The Singapore Zoo, they actually have a course on how to make paper from recycled paper. You know, sometimes they say don't throw away paper, it's for recycled paper. So basically, recycled paper is paper made from other papers. But you can only do it a few times until you can't do it anymore. Okay, if you compare the paper that you have with the paper from a newspaper, you realize the newspaper is very thin because newspapers are usually made from recycled paper. Okay. Okay, moving on. The next material we learned about was metal. Now, metal we get from digging up from the ground. Okay, so different types of metals such as gold, copper, and aluminium are metals that are found naturally in the ground. So if I can show you a picture of the Earth's crust. The crust is okay. Size to okay. So basically, if we were to cut the Earth looks like a ball. So if we were to cut the Earth, we can see that there are many layers in the Earth. In the middle of the Earth is this thing called the inner core. It is basically melted iron. Iron is a metal. Okay, the metal that you find in your chair there is a type of iron that has combined with carbon to form steel, right? But if you heat it to a high enough temperature, it will melt and it will become molten iron. So that is what we find in the middle part of our Earth. Surrounding it is other metals and soil, right? Then the mantle itself, this is your magma or lava, the one that comes out from the volcano. Okay, so how do we get metal from inside our Earth? Well, basically in the middle here, since it's so hot, right, it actually transforms different elements into different metals. Okay, then because it's liquid, right, it will flow out to the top of the crust. And at the crust, we can dig far enough to find this metal. Okay, so if I show you, for example, a copper mine. Copper mine. So what happens is human beings will actually cut into the earth. Okay, you can see down here there are small cranes. Okay, so this used to be a mountain. They found that the mountain has copper in it, so they used to cut. Okay, and then they collect the ore. Okay, you can see these trucks here. They will carry the soil that has been dug up to a plant or factory where they will separate the soil from the copper. We want the copper. The soil, they will put back inside the hole when they're done. Okay, you can see up here is all the soil that they have used. So later when they have finished digging, they will push all this soil back into the ground. So this is another picture of a copper mine. Most mines look like this, whether it's copper or, for example, gold mines. Okay, so this is what it looks like inside the earth. So you can see these streaks of gold. So basically, they will dig this up. But if gold is mixed in with the rock and the soil, so they must actually separate the rock and the gold from each other. This is, yeah. So this is what gold looks like when it's inside the ground. Okay, so like if you play Minecraft, you should know lah, right? Put the ore into the minecart, then you push the minecart out. So why is gold important? Gold is important because it has several properties. And it's very rare. Rare meaning there's not a lot of it in the world. So it's only used to make certain things. For example, jewelry. Okay, if you notice, gold tends to go up in price over the years. So if you want to save money for the future, instead of putting your money in the bank, you might consider buying gold. Because the gold that you buy today, let's say you buy $100 worth of gold today. So in 10 years or 20 years, by the time you grow up, that $100 may be worth $1,000. Okay, so that's why it's gold up. Right? Another one is people use it to make jewelry. Jewelry because it is nice and shiny, and it doesn't lose its color. All right. The next type of gold we usually the next type of gold. The next type of metal we usually see is iron. Iron is used to make things which we require to be strong, which is like your chair legs. You see this thing here, this is iron, right? Anything that requires to carry a lot of weight, we will make out of iron. So the bars on your windows, these are all made of iron. But the problem with iron is that it is very brittle. Meaning if you were to use pure iron, if you were to hit it with a hammer, it will actually break. So why is it that our window grills are not made of pure iron? It's because the iron is mixed in with other uh, elements, for example, carbon to make steel. Okay, it's called an alloy lah. An alloy is basically a mixture of, and spell it for you, huh? An alloy is a mix of a metal and another element. So element can be carbon, can be zinc, is another metal. All right, all these things lend properties of strength to certain metal parts. Okay, we have. Okay, we are on this page. There's no page number, so you turn to the metal page. You don't need to copy down because all the notes have been filled in for you already. Okay, so just turn to this page lah. Yeah. All right. So we tend to mix iron with other things to make it strong. We as human beings also have iron in our body, which makes us slightly magnetic. It's not like if you were to bring a magnet close to your body, it will stick to your body. It doesn't mean that. If there is a strong enough magnet, you can actually be attracted to it because of the iron content in our body. What is iron used for in our body? Iron is used in your blood cells to carry oxygen around your body so that you stay alive. Okay? So iron is a metal that is found inside our body lah. Right, copper. Copper is usually used to make wires. So whether it's this cable here, whether it's a charging cable, a data cable, like this is a charging cable, right? This is a data cable. This is HDMI connects to the TV. So no matter what kind of cable it is, most probably inside is copper. Why? Because copper carries conducts electricity very well. Is there a better conductor of electricity? Yes, gold is a better conductor of electricity. So why do we make our wires all out of gold? Inside these lights, all there are wires. So why do we make it out of gold? Because gold is very rare and expensive. In fact, you can buy gold-plated wires. No, they do sell them. Like you go Challenger, right? There is this whole wall of cables. Okay? HDMI cables, USB cables. You can actually find a few that are gold-plated. But if you look at the price, it's more expensive than a normal cable. Normal cable like this, maybe $1, $2. But a gold-plated cable can go maybe $10, $20 because there's gold inside. Okay? But because we don't want to use gold, we use copper for all our wirings. So whether it is this power cable, your aircon cable, your phone charging cable, all these will contain copper inside. Copper has this very, it looks rose goldish. Okay, in fact, if you look at it, you will say, hey, it looks like rose gold. It's not really rose gold. In fact, in the past, people used to call copper fool's gold. Fool's gold means that it looks like gold, but it's not actually gold. So you look at the picture over there. If you compare it to this gold, how do we know it's not gold? Gold, when you find it, is usually very smooth. But copper, if you find it in the ground, is very rough. So that's why we know it's not gold. Okay? Another one is we use it for cooking pots. Why? Because it has a very high conduction of heat, meaning it transfers the heat from the fire to the food that we are cooking very well. The problem with that is you will notice only the outside of the pot is copper, inside is not copper. Because copper, in contact with certain foods, will actually leach into the food. What's the meaning is the copper will react with the food that you are eating and enter your body. And that is not good. Okay? Iron is okay because your body has iron inside, but your body has no copper inside. Alright, so that's why the inside of the copper pans or the copper pots are actually steel. They are not copper. Because if we make it out of copper, it will react with our food. In fact, there's a very interesting story about in the past, there in the very distant past, about 500-600 years ago, people used to have plates and bowls made of lead. Lead is Lead. Lead is a metal. Okay. In the past, people didn't understand lead is dangerous for human beings. But they made plates and bowls out of it because they found that it's easily available and stuff. And about 500 to 600 years ago, human beings traveled to South America and they discovered this fruit. And they brought this fruit back to Europe. And in Europe, wait, let me finish my story. They brought this fruit back to Europe and they cooked dishes with it and they ate off of the plates and the bowls. And they ended up dying. The fruit was the tomato. Nowadays, we eat tomato is okay for us, correct? But back then, people used to eat tomatoes and then they died. And they thought that the tomato was a poisonous fruit. It was not poisonous. What happened is that the tomato contains a certain type of acid that when you put it on a plate made of lead, it will change the lead into something that you put inside your body. And when you put something that's dangerous inside your body, that's when you die. So in the past, people thought that the tomato was poisonous because every time somebody ate it, they will die. Okay? But it was not true, it's because they used the wrong type of metal. So that's why I say the first thing we need to consider whenever we make something is how safe it is. Alright? So that's the story of lead and tomatoes. But copper is the same. That's why you only see the outside of the pots and pans made of copper. Second reason people don't use copper a lot. In fact, if you go home, you see your mom's pots and pans, they are not copper. is copper tarnishes very easily. Tarnishes means it gets dirty very easily. Okay, and copper when it tarnishes, okay, show you what it looks like. I don't know if you all have, but last time when I was in school, primary school, I used to wear a watch. And the watch at the back of it, there was uh, there was a bit of copper. So copper, when it gets tarnished, it looks like this. This green thing comes out. It's not a living thing. It's just tarnished. You know the most famous thing that is made of copper in the world is the Statue of Liberty. It's not supposed to be green. The Statue of Liberty is made of copper. It's supposed to be that golden color that you saw. This golden color. But because it is out in the sun and the rain so much, over the years, all of the gold color disappears and now it has turned green. So this is copper tarnishing. So you imagine, no matter how much you wash, this color will not go away. Okay, so you can see pots and pans, and this one is new, so it's old. So you see, would you want to eat out of something like this? So the answer is no lah. So that's why we don't usually make things out of copper. Right? So it's a pot. You can see it gets dirty very easily. Is more easier than other types of metals. Okay? Okay, the last type of metal you need to know about is aluminium. The spelling here is a British spelling. If you hear Americans, they will say aluminum. Okay, because they don't have the I in front of the U. Yes, it's just ALMINUM. Aluminium is one of the most common metals that we have in the world. In fact, we can make a lot of things out of aluminium. If you look at the light, you see the shiny part of it. Looks like a mirror. It's not actually a mirror. That's aluminium. Okay. This card here, the silver part, that is aluminium. Okay. More commonly, aluminiums are used to make cans. So the drinks that you buy in the can, those are made of aluminium. So why we use aluminium? Because aluminium is very safe. It doesn't react with anything. It doesn't react with electricity, doesn't react with food. Okay? Other things we make out of aluminium includes our windows. But you say, okay, the windows are hard. How come they are hard? But the can is soft. You can crush a can, correct? But you cannot crush a window. The aluminium that is used in a can, in the construction of windows and in the construction of the plane's body are all different types of aluminium. Okay? Okay, I don't know if you all have ever followed, don't know if you all were alive also. There was a trend a few years ago where people would take an aluminium ball. It started by this Japanese guy. He basically took aluminium, okay? The aluminium that your mother has at home, this one, he makes it into a ball. He takes many, then he make it into a ball. Then he will polish the ball to become this shiny ball. It looks very heavy, but it's actually not heavy at all, right? This is a trend a few years ago. I don't know if you all were alive back then. So many people tried doing it. So you see, some people got it to become very shiny. Most people not very shiny. Okay? So like this one, you see, it started very big. Then by the time it finished, it became very small. So aluminium is so cheap that people could do this kind of useless things. Because if you ask me why they do this, because if you remember during COVID, right, we cannot leave our house, correct? We were all stuck at home, correct? And we all had a lot of aluminium at home. So we all started doing this. It's just to pass the time. Okay? How long? Then some people have this belief that aluminium can stop x-rays and stuff. All that is very fake. Okay, so important thing about metal. Why don't we use metals for more things, right? Why do we use it only for pots and pans? Even if in pots and pans and in cans, why can we not put it inside a microwave? Because metals can conduct electricity. Okay, so what is a microwave? A microwave is basically it emits waves of radiation. As the waves pass through a metal, it will form a magnetic field, and if the magnetic field were to cross each other, then a fire will start, which is why metals are not allowed to be put into the microwave oven. If you notice your mother, every time she wants to use a microwave oven, she either transfers the food into a plastic dish or a plate that's made of ceramic. We cannot put metals into the microwave. Would you all like to see what happens to metals in the microwave? What happens when we put metal? Okay, let me find a short video. That sound. Okay, you can see this person is putting in. Wait, I haven't shown.
If you are not careful when putting food in the microwave, it could be your last meal. The electromagnetic waves in a microwave oven cause a rapid buildup of charge on metal surfaces. If the metal has a rough surface or sharp edges, such as aluminum foil or forks, the charge accumulates at these points, creating sparks. When these sparks combine with oxygen, they can cause small explosions. If you are not careful when putting food in the microwave,
Okay, that's why we don't put metal into a microwave. Okay, so there's another reason why sometimes we need to choose the correct material to make our food containers lah. All right. Next. Ceramic. Ceramic was the second thing that human beings discovered they could make things out of, which is why you find very old toys made of ceramic. Okay, so what is ceramic? Ceramic is basically clay. What is clay? Okay, our soil is made up of different type of rocks, I would say. Are they rocks? Okay. So most of you have this. If your mother or your parents do gardening at home, you've seen this before, right? Right? Okay. If you look at this, there is the big chunks, there's the small dark chunks, then there's that one. That is substrate. Substrate basically means it's very, very fine grain like sand. So different plants grow in different types of soil. Okay. Clay, this one here, it absorbs water to a certain point. After that, it becomes hard. Okay, usually the mud that you see is made out of this. Normal soil mixed in with water. This one will never become mud. This is sand. Okay? Clay, on the other hand, it tends to stick. And in Singapore, if you ever see a construction site, you'll notice the clay in Singapore, right, is very red. Singapore is covered in clay, which is why we don't have farms. Plants cannot grow well in clay. Okay? So if you look at our soil, it is very bright in color. Not like other countries. Okay? Now, clay, if you collect enough of it, it looks like that. You add water to it. You know your plasticine? Have you ever played with plasticine before?
Yeah.
No? No?
The plate.
Play-Doh.
I got the
Ah.
plate.
Play-Doh, you can shape it into different shapes, correct? Play-Doh is a toy that borrows its idea from clay. So basically what we do with clay is that we add a lot of water into it to melt it. Not melt it, sorry, dissolve it. Okay, once it's dissolved, we can then take a lump of it, like Play-Doh. Okay, we take a lump of it and then we shape it. We shape into a bowl or a plate or a vase. These are fake teeth called dentures, right? So one of the first things humans discovered after wood was that clay can be used to make houses. That's why they make it out of clay bricks. In fact, if you still look at countries like Africa, people, not countries like continents like Africa, where people live in the mud huts is actually made of clay. Okay? So how we do it? We add water to it to make it soft, and then we take a lump of it and we shape it into whatever shape we want. So here they make a base. After you make it into a shape, you must then dry it out in the sun or bake it in a hot oven, also called a kiln. Alright? So when it goes inside the hot oven, it actually dries. All the water inside the clay comes out and comes out as water vapor and steam. So this one then becomes our new thing that we made of clay. Okay? So ceramic needs to be shaped, it then needs to be dried or fire baked in a hot oven, heating hardened ceramic, but it breaks easily. So ceramic is the same as the next material we're going to learn about, which is glass. But ceramic is made from clay, glass is made from sand. Where's the glass? Here. We skip rubber for a while, we go to sand. So you'll notice a lot of the materials we make things out on the earth is actually made from the things we find around us. There's a lot of trees around us, so we cut them down to make the things that we need. There's a lot of clay around us, so we dig it up, we add water to it, we make certain things out of it. Metals, after we dig out the clay, we also find that there are metals in the ground, so we use it. Glass, we find it from the sand that we have. Okay, but not the same sand that you find on the beach. That sand is not the same type of sand that is used to make glass. The sand that is used to make glass is very fine. It's actually called sand glass. You know, if you use it in Minecraft, you melt the sand, it become glass. Okay, not so. This is the owl hand. Okay. Now, the sand that we use to make glass looks like this. It looks like small, tiny pieces of diamond. It's not diamond, huh? Okay, diamond is made of carbon. Glass is made of silicon. Okay, so we can use the sand that we find on the beach. Okay, the sand that you find from the beach looks like this. It has small specks of white, black, red. So what are those white, black, red? They are actually small particles of sand. Sand under microscope. This is what sand looks like under the microscope. Okay, so you can see these white ones. Okay, the clear ones are usually used to make glass. You can see this looks like a tiny snail shell. This one is another tiny snail shell. Okay, because sand that you find on the beach is not just sand. It's also made up of the bodies of small animals. Like this is a piece of coral. Okay, this is a coral, this is a coral, this is another shell, this is another shell. These are rocks lah. Okay. So when we have a lot of sand, the sand that you find on the beach, this is what it looks like. So you can see there's the black one, the brown one, the red one, the yellow ones. That is why sand on your beach looks like it has a lot of colors. But we cannot use this sand to make glass. If you look at the sand used to make glass, it's all one color. Okay, where is the picture? There's no color here. The sand that is used to make glass is all of one color. So why is it all of one color? Because they have removed the silica from the sand and used it here. So what happens to all the seashells and coral? They throw it away. They only want the nice white one, the nice ones that look like this. Okay, can? Then the process is almost the same as the one you find in Minecraft. Okay, they not boil, they heat up the sand. I know you put the coal, you put the sand on the coal, the fire will die. So basically, okay, let's find a video, okay, to explain it. They will put it inside what is called a crucible. A crucible is this pot that's made of ceramic that allows it to be heated up to a very high temperature.
Now it was high.
We cannot melt sand ourselves.
That is survival. Survival.
Okay, let's watch this short video, huh?
Glass, a product of nature's bounty, is crafted from abundant raw materials, setting it apart as an environmentally friendly choice compared to metal or plastic. Its recyclability knows no bounds, whether in colored or crystal clear forms. The essence of glassmaking lies in a recipe that harmonizes various natural elements, with silica sand, soda ash, and limestone taking center stage. Silica sand, comprising around 45% of the mixture, forms the backbone, while soda ash, contributing 15%, ensures the even melting of silica. Limestone, at around 10%, imparts durability to the final glass product. This blend is then complemented by recycled glass, known as cullet, seamlessly integrated into the manufacturing process. Precision reigns supreme as the factory's equipment meticulously feeds predetermined.
Okay, so you can see this thing here. This is called the crucible. Okay, can see the fire below is very, very hot. It's hotter than our normal fire. Okay, we use it to melt the three elements
Ounce
that
of
you
these
saw.
materials into a furnace. Over the course of 24 hours at a scorching 1500 degrees Celsius, a molten liquid that's the consistent.
Okay, so you see the thing that's coming out is actually the liquid glass. So that's the melted sand just now, the sand that they had, they melt, then they push it out of here to form these small things.
Sea of honey emerges. The molten glass is then channeled at precise intervals, forming cylindrical globes, each destined to become a bottle or jar. They then drop to the scoop, a device ushering these globes to troughs that guide them to jar and bottle forming machines. A glob of molten glass undergoes a swift transformation within a preliminary mold, emerging as a parison, a miniature version of the final bottle. These parisons then journey into a blow mold where compressed air shapes them into the desired bottle form. In the case of colored bottles, the glass mix incorporates small amounts of iron, sulfur, and carbon. This meticulous process extends to clear glass production. A special mold may feature a recessed insignia, resulting in a raised design on the bottle surface. The bottles travel through flames to prevent rapid cooling and potential thermal shock-induced cracks. Gradually, they enter an annealing layer, cooling at a controlled rate to release stress from the glass. Lubrication aids their smooth progression through subsequent inspection and packaging stages. The bottles undergo rigorous automatic inspection. Cameras and probes scrutinize each bottle for imperfections, ensuring a flawless final product. From dimensions to thread integrity for screw caps, every detail undergoes meticulous scrutiny. Finally, a visual inspection seals the quality assurance process. Here lies the unique advantage of glass production. Up to 90% of the mix can comprise cullet. This inclusion, melting at a lower temperature, translates to a remarkable energy saving of up to 2.5% for every 10% of cullet used. A clear incentive indeed, underscoring the sustainable journey from sand to shelf. Thank you for watching.
Okay, so that's how glass is made lah. Right, so if you notice the last part there, it says after the glass, the molten glass is glowing because it's so hot. After it's put into the press, air is actually blown into it to make it expand into the shape that you want. Okay, so there is actually this art form called glass blowing lah. I don't know if in Singapore you have it. But to make glass, basically you must blow into the shape that you want lah. Show you a picture. Not shopping, sorry. Okay, if you ever seen videos of people like this, so you can see the man, he's blowing into this long tube. At the end of it, there's this piece of glass
What is more power?
because it's very hot. So the glass blowers must actually stand very far away. It is very hot. Okay, so they blow and then they spin it to make the shape lah. Basically, whatever shape they want. So then they will use things to cut it and stuff. So it's an art form lah. You see some of them can make very nice colorful ones. So they will add colors into it to make it look nice. Right? So that's why when you see things that are made of glass that are sold in the shops, for example, vases and all, they cost a lot of money because it's very difficult to make. Okay? So glass is used to make certain things. For example, your glass tanks for your pets at home, your window panes, light bulbs, okay, and your spectacles if you wear spectacles. But not these spectacles made of plastic, are not made of glass. Right, second last is your rubber. We go back to the page before. Rubber can come from two places, either the sap of a tree or from the oil that we get from the ground. Okay, so we use rubber for things that require it to be bouncy, to protect things. So you notice rubber is usually made into toys, tires, rubber bands, and then to protect yourself, rubber gloves, raincoats, and rain boots. Okay. Not many people are allergic to rubber. There are some people who are allergic to rubber, but very small amount. Okay. The last material you learn is plastic. Of all the materials that we use nowadays, most of the things, not last, there's another one after this, but most of the things we use is made of plastic. See, this bottle is made of plastic. This table is made of plastic. This laptop is made of plastic. My phone, the back of it is made of plastic. Right, the chair you're sitting on is made of plastic. Your EasyLink card is plastic. Some of you wear shoes made of plastic. The Crocs are made of plastic. Right? So why do we use plastic to make so many things? Number one, plastics are very safe for human beings. No one is allergic to plastic. What I mean by no one is allergic to plastic is all of us can touch plastic things. Not a single person on this earth cannot touch plastic things unless they choose not to lah. Alright, but no one is allergic. They touch, they will die. Don't have. Okay, number one. Number two, if you remember just now I say, whenever you want to choose something, you must look at the price of it. Plastic is very cheap. Where do we get plastic from? We get plastic from oil. You know the oil that we dig into the ground for? You know where oil comes from? Hey. Where does oil come from? Okay, this one. Oil, you know the black color thing that comes out from the soil, that countries like Brunei become very rich because they have a lot of oil. It comes from under the earth. So whether it's under the ground or in the sea, under the sea, it is oil. Oil is all the way under here. Okay, the oil is pumped up to the surface either through a gas well or an oil well. That's why sometimes you see pictures of oil rigs at sea. Have you seen oil rigs? This one. If you ever take an aeroplane, right, and it's flying over the ocean, sometimes you'll be able to see these buildings out at sea. These buildings have a long tube going down that pumps up the oil from under the sea, okay, into ships. The ships will bring the oil to the land. Or okay, in Singapore, if you ever get to go to Jurong Island, if your school ever brings you for a learning journey to Jurong Island, you will notice Jurong Island looks like this. These circle things are where we store oil. The ships bring the oil to the land. They will stop here. You can see there's a ship there. Can see now. This is the ship. The oil will be pumped through the pipes and stored inside these tanks. All these tanks contain oil inside them. But we cannot use the oil straight away. We must then bring the oil to an oil refinery. This is an oil refinery. So basically, we change the oil from the black color things into the things that we need. So what do we make from oil? Anyone? The fuel that your father's car runs on is made from oil. Okay, so the oil, the black color, comes into the oil refinery. They heat up the oil. They don't burn the oil because they burn the oil, the whole thing will catch on fire. They heat up the oil inside the pipes, and the oil, when it's heated up to 25 degrees or less than 25 degrees, it becomes the oil, the gas your mom used at home. Between 25 to 60 degrees is the oil that your dad uses when he drives the car. Okay, naphtha is a type of, we use it for road building and stuff, along with bitumen. Paraffin is a solid that we use for aeroplane fuel. Diesel, for those big trucks that you see, they use a different oil from the car oil that your dad uses. Fuel oil is used for ships, lubricating oil. So we get all of these things from just the one oil. Okay? So where is plastics in this? Plastics is somewhere between naphtha and paraffin. The plastics production will be somewhere here. Okay? So, because oil can make so many things, and plastic is considered a byproduct. Means when we change oil into the different parts that you saw just now, some of it will become plastics. That's why we can make things out of plastic. And the things that are made out of plastics are all very cheap or expensive. Cheap. Plastic bottles, shoes, toothbrush, plastic bag, pens. Of all these things, the plastic bag is cheap. Remember, if you go to supermarket, you only have to pay 5 cents for this. Right? Pens are also quite cheap. You can get pens for 50 to $1, 50 cents to $1. Plastic bottles, you buy the bottles at school, maybe 50 cents or $1. Alright? In your shop, how much is the plastic bottle? 80 cents. Okay? You know how much she buys from the shop? When you buy from your shop at school, the auntie who sells you buys it from somewhere else. You know how much one plastic bottle costs of water from the factory? 25 cents. 25 cents you get the plastic and the water inside. Okay? So it means the bottle is very, very cheap. So plastics are actually very cheap. But why do we use plastics? Or why is it very dangerous for us to use plastics? Anyone wants to guess? Eat plastics. Okay, we don't eat plastic. But plastic takes a very long time to break down. Okay, basically, things break down over time. Like wood. Wood can rot. We know what's the meaning of rot. it will become weak over time, and then it will break down into smaller pieces. Okay? Metal, clay, glass don't break down easily, but they are not dangerous because they exist in nature. Glass is from sand, ceramic is from clay, both found in nature, correct? Everywhere is everywhere. Wood comes from tree, also found in nature. Metal is found in the ground, also found in nature. Plastic is not found in nature. Plastic is man-made. So because it's man-made, it takes a very long time for it to break down into smaller pieces, number one. Number two, even when it breaks down to smaller pieces, it doesn't disappear. It cannot turn back into oil. So what happens? Don't know. Okay. So basically, animals, especially fish, have been caught, and we have found in the stomachs of the fish pieces of plastic. For example, this is a real fish. They cut open the fish. They found inside the fish, this is a plastic bag.
So if we eat fish, even the fish eat the plastic, then we eat also plastic.
Okay, not necessarily, because the plastic is found inside the stomach of the fish. We don't eat fish stomach, we throw away the stomach, correct? But the stomach of the fish will absorb the plastic material into the flesh of the fish. So if we eat the flesh of the fish, soon we will also have microplastics in the body. Okay? So that is why plastics are very dangerous. In fact, if you look at this picture, this is a real picture, it's not AI. The fish is actually living underneath the plastic rubbish. Have you been to Bali before? Anybody been to Bali before?
Right.
Bali is in Indonesia. So in Bali, they have a trash problem because there are so many tourists in the country. The tourists throw their trash into the sea. So you see most of the trash here is plastic. I say plastic. Most of it is bottle lah. Okay. There are some trees and branches, but most of it is plastic. Okay, you cannot see very clearly, but you can see from here the small ones, plastic cups, plastic bottles, mixed in with all the other things. So this is what a beach in Bali looks like. You can see how much rubbish there are and how much of it is actually plastic. So plastic cannot disappear unless humans are responsible and we recycle the plastic. For example, if you look at this bottle, it says I am a 100% recycled plastic bottle. Meaning that this bottle was made from all these other plastic things. They break down the plastic, they melt it, they form it into a new bottle. So that means once I throw away this bottle will become recycled, it will become a new bottle for somebody else to drink from in the future. Okay? It's the only way we can get rid of plastic is to reuse it. If not, our whole planet will start to look like this. Have you watched Wall-E before? Have you watched Wall-E before?
What?
You've If you watch Wall-E, this one, this robot thing, he is actually a trash management robot. I can't remember what it stands for. So if you look at his planet, right? His planet is covered in rubbish. So why they look like Lego blocks like that? If you watch Wall-E, his body is a square, right? So he will take the rubbish, he will put inside his body, then he will squeeze all the rubbish together, and then when it comes out from his body, they will form blocks like that. So he arranged the blocks to become mountains of it. Yeah. Okay. So this cartoon is trying to tell us if we don't take care of our plastic problem, one day our earth will look like this. That's why in this story, the humans left the earth. Okay? Okay, now it's a good time to take a break before we go on to fabric. I can have a 5 minute break. Then after you can come back. Okay, have fun.
That's why I don't like talking to students very because again it's hard for us to manage some students joining in the middle of December, so many study class. But some of them just start. Like what Mr. Frank did. So some things just go in for you. Unless it does every day, then you have to answer the question. It's really hard to manage. Like you find time management for each of the topic. It's really hard. You can see if it's like a hard game to review. I saw I'm not ready for Friday. I need to send up for Friday class. What is this? 28 now. Fine, very traditional class. Oh, good.
Yeah,
Your Jurong class.
still that one girl,
What class are you did here for?
science, P3. Same
I don't think it's for brother anymore.
in Jurong.
Yeah.
No, it's still her because okay, I told Israel lah. Because last session was supposed to be the last session. But remember the mom said they only want the trial for 1 month.
Oh.
So
the blanket yeah.
no, because initially she went for the first trial assignment.
Yeah.
Then me and the Akid is the math teacher who teaches on Saturday, so he gave the mom feedback. So Akid's class is a mixed class. It's her and a few other students. And it's obvious that she cannot follow the pace and follow along the lessons in a normal class. Whereas for my science, she's a medium. Okay. So after that trial lesson, me and Akid gave the same feedback. Is that if you want to continue, then it's best if you get a one-to-one tutor. Because if there's other people in the class, number one, she will be distracted. Number two, she herself will be a distraction. Okay. So then the mom pleaded the case that she just wants to try for 1 month. Okay. So for 1 month, Akid had her in his class. At the end of 1 month, Akid's feedback was, I cannot. Because if I have her in the class, the other kids will suffer. She's very slow. Slow in the sense that you need to cajole her to copy down. And science is a lot of notes. Math is a lot of practice. If you cannot sit down and apply, you will never progress in the lesson. Okay? But for me, it's okay because she's alone. So I can take my own sweet time for it. Right? But after that 1 month, apparently the mother feels that it's okay, she gets to know the teachers already, she's okay.
Does she not hear the feedback?
Exactly. It's like she's in denial. So for Akid's case, I don't know if it continues or not. But for me, I say that if she wants to continue, I can teach her one-to-one. But you must remember that forever, my this one girl will be in a small class. Now is it fair for you to pay me $75 for session? Okay? And I'm teaching an autistic kid now. Oh, you didn't know?
Like, no offense.
I think knows the story.
Yeah. Just it's not actually never heard of it. You should have looked at this.
So I told this already. If there are future PhD science students, the classroom, class 3, right, it's not being used from 9 to 10. I can conduct a normal P3 science class 9 to 10 people, and 10:45 I told me, then at least not so bad, no. At least I will still have the numbers not to kids. Because this one girl is preventing me from having a normal class.
I think I was a basic foundation, so then for Woodlands is for special needs. Like when I chose a race, I understand that we have like past users shops. It's like patient inclusion. It's good that you want to take up this, but I think we should check out. Because it's next one. Yes, it's so good. If I'm looking, yeah, so I what's it? I was supposed to be the one doing my work, but he wants to do it, which I think is smart. I don't know if personally, really, you should be the that basic foundation, I get that you know. His attention span is everywhere.
Yeah, his attention span is everywhere.
Yeah.
But okay, to me, when it comes to students, Talish as compared to Adam, maybe Adam is 5 years, but then it's my second same Talish. I can work with someone like Talish. The attention span berterabur. Tapi dia bila dia buat, he has a certain measure of respect. He knows you are coach and student. Yes. Adam is a new kid. Hi, how is you do? Yes. Tapi dia punya is, I don't know if he trying to test water as well. Like the room is cold, so I told them, okay, it gets too cold, just let me know. So then the rest of them will be complaining that it's warm. Like the rest are back. So then when Adam said, chill, room very cold. I said, okay, why are you cold? I'm cold lah.
When before you even came in, I had the class because his first day, so when he had me, did you like wait?
Did you
Exactly. Oh, like yo, and he doesn't look like the.
But Talish is okay. Only Talish is okay.
That guy's very cheeky lah.
But I would rather a cheeky rather than 5 years.
Well, I think so far discipline quite a few for very good areas. I mean, that's enough. That was the last one.
Today is first time with me. So I have to monitor him first. But everyone like say it could be testing water. But some of these kids they move from standard to foundation. They feel aggrieved. Macam asal belum di foundation so they come here thinking that I don't need this. Foundation is P4 already. The P4 is really don't have to be tuition. So they don't really understand that we are here to help them. But if they make it difficult for themselves, they never think they are. Let's go. Welcome back. Why is everybody so sad? Is it because Monday have to start school?
Yes.
But your P1 brothers and sisters already started yesterday, what?
I don't have answer.
Then you can take MC. You got reason not to go to school. But if you miss the first day of school, you will miss a lot of things. Because first day usually got no lesson, right? It's usually talks and activities. It's okay lah. Next year P3 will be fun. Okay, back to this one. The last material we learned is one of the most important materials. Why? Because this material is the thing that protects humans the most. And this material is called fabric. Okay? So what is fabric? Fabric is basically cloth lah. Okay? Human beings realize a long time ago that we need to cover ourselves up to protect us from nature. Whether it's other animals. Okay? When I say other animals, don't think of why we must wear clothes to protect us from elephants and no. When I say animals, it means insects. If we don't wear clothes like long pants or shirts or jackets, if we go out into nature, there are a lot of insects, correct? You have ants, you have mosquitoes, you have flies, you have bees and wasps, and all these insects, they don't want to hurt you, but sometimes they have no choice. They want to protect themselves, that's why they bite you. Okay, to let you know that they are there so that you will move away from them. So humans discovered that we need to protect ourselves from these animals, so that's why we cover ourselves with cloth or fabric. Another reason is we need to protect ourselves from the elements. Elements basically means the sun, the rain, wind. Okay, like these past few days or past few weeks, it's been raining in Singapore, correct? I'm very sure none of us like to walk around in the rain. Why? Because after we walk around in the rain, what happens to us? We fall sick, correct? So usually to protect ourselves from rain, we use an umbrella. If not, then we wear a hat. Okay, so to protect ourselves from the element. Another one is we wear clothes so we don't get sunburned. Okay, usually if we are out in the sun doing activities, whether it's playing sports, whether it's walking around, okay, and the sun is very hot, we tend to get sunburned. So we wear clothes to prevent that from happening. Lastly, you realize humans are not like animals. Our outer covering, although it's hair, is very few on our arms, right? Or on our bodies lah. On our heads, there's a lot, okay? But the rest of our body is not covered in hair. The reason why animals are covered in hair, for example, the sheep here, is to keep their bodies warm. Okay? And if the weather gets warm enough, they can actually lose their outer covering so that they become cold again. But they can grow it back. Human beings don't have that because our only hair is out here, right? Okay, so fabric is a material. Usually it comes from two places, plants or animals. But recently, more and more of our materials for fabric comes from plastic. Like for example, you see my shirt here, it's made of polyester. Polyester is a type of plastic. Okay, but in the past, most fabric comes from animals or plants. For example, this animal here is called a sheep. Sheep are covered in wool. Okay, and wool covers the sheep, and we use the wool to make things like sweaters and stuff. Okay, have you ever seen picture of where the farmer takes the wool? Yeah, they use the shaver called a shear. Okay, it doesn't hurt the sheep will not die from it. Okay, the sheep is still very much alive. It's just like the farmer holds the sheep. You can see he puts the sheep's hooves up here so that the sheep his hands are little. Okay, but the sheep is still alive. Then he used the shaver, the shears to strip away the wool from the sheep. Okay, this one is nicer lah. The farmer just let the sheep put his head there. So you can see the shaver here shaves off the wool from the sheep. Now why must the farmer do this? Because if the farmer does not shear the sheep, the wool can grow too thick and the sheep can actually overheat and die. Let me show you a picture like that. So this sheep here, his wool has grown too thick. So can you imagine on a hot day, he's covered in all this wool, his body will actually overheat and he will die. So that's why the farmer needs to remove the wool from the sheep. Okay? So some farmers, after they remove the wool, they will give the sheep a blanket so the sheep will not feel so cold. Right? But the sheep is still alive lah. So that is wool. Second one is silk. Silk comes from the silkworm. So you see the animal there? That's called a silkworm. It's a kind of caterpillar, right? It builds a cocoon. The cocoon is that round ball that you see there. Okay? Because it wants to turn into a moth. Right? But the caterpillar, when it goes inside the cocoon, before he can turn into a moth, they have to kill the caterpillar so that they can remove the caterpillar from the silk. Then they will use the silk to make things such as scarves, bed sheets, and dresses. Okay, some of you have silk blouses or silk dresses that your mom buys for you, especially on your special occasions like Deepavali or Hari Raya. Some of the ladies wear silk. Okay, the good thing about silk is that it's very light, it's not heavy, it allows air to pass through very well, but it is expensive lah. Because you can imagine to get the thread, they must take it from that small caterpillar, that small piece. Like one of these cars will use hundreds of those cocoons. Alright? So that's why it's expensive. The last one is cotton. Most of us, our clothes are made of cotton. Your school uniform is made from cotton. Why? Because cotton is very cheap. Cotton comes from a plant. Okay? Although a few years ago, your Minister for Education said cotton comes from sheep. So that means at P3, he never listened to his teacher. Cotton comes from a plant. Wool comes from sheep. But the Minister of Education said cotton came from sheep. Okay? But you now learn cotton comes from a plant. And cotton is used like your t-shirt is made of cotton, right? Your school uniform is made of cotton. Your towels at home made of cotton. So why cotton is used? Number one, cotton is cheap. Number two, cotton absorbs water very well. That's why we make a lot of towels from it. Okay? So why are shirts made of it? Because we also, when you sweat, especially in Singapore, your uniform actually absorbs your sweat, right? But you'll notice the sweat dries off very quickly because cotton allows it to do that. Your towel, not so much, because your towel is more thick. Okay? Okay, what are the physical properties of materials? Not really. Wool is very much warmer than cotton. Okay? Singapore, we don't usually use wool unless we're making sweaters or socks. But the disadvantage of wool is that when it gets wet, it becomes very heavy. Cotton, if it gets wet, it doesn't become heavy. You know, like your towel at home. After you dry yourself off, the towel is wet, correct? But it's not very heavy. Wool, if you were to absorb water, it will become very heavy. So that's why we don't make things out of wool. Okay? Alright, moving on to the physical properties of materials. Why we choose a material, I say, is what that material can do for us. In fact, a few days ago, your parents have gone down to your school to buy your school books. Alright? Did you notice your school books? When your parents bring them home, it was not in a paper bag. Why was it not in a paper bag? Because if your parents were to put your school books into a paper bag, it will break. Most probably, when your parents brought back the school books from the school, they were in a plastic bag. But here is a fabric, because fabric, like the bags that we carry, you see my bag and Safia's bag, is made of fabric. Why not made of plastic? Because plastic can also break, but fabric will not tear easily. Okay? So we choose fabric to make our bags because if we want to put heavy things inside, we must make sure that it will not break. So that is one thing we must remember. So by knowing the properties of different materials, it becomes clear why certain materials are chosen for different uses. This understanding makes it easier for us to choose the suitable materials for making specific objects. Okay, so what are the physical properties of materials we care about? Number one, we care about the strength of the material, its flexibility, its ability to float or sink on water, waterproof or absorbency, and lastly, transparency. Okay, so last week I asked Pritya this question: why does a ship made of metal not sink into the water? Metal will sink, right? Metal is very heavy, right? But why is it that the ship that's made of metal doesn't sink? Okay, that is because the property of buoyancy. The skin of the ship is made of metal, correct? But inside the ship, there's a lot of air. Air is lighter than water. Hmm. So because there's air inside the ship, it allows the ship to float. The weight of the ship and the air inside it is less than the weight of the water around it. There's no air inside inside the ship, that's why it will sink. That's why if there's a hole in the ship and the water goes inside, the ship will sink because the air comes out from the ship. Understand? That is the thing about buoyancy. Okay? Okay. Time for you to copy things down. Yeah. Let me pull out this one so I know what I am doing. Okay. What is this? Okay, the strength of a material is its ability to be what? We find, huh? What do you think? Air. Oh, ability. Wait, I know. Yeah. Primer. Oh, okay. Okay. To be stretched or support without breaking or failing. Failing means Some things don't break, okay? Some things tear. For example, fabric will tear. Okay? So, different materials have different strengths. Some materials do not break easily, even if they are okay. Hold on, I need to check with coach.
I think they have that is like proper.
Okay, I'll check with you. Right. Okay. I will give you a preliminary answer. Then next week I will confirm again with you, okay? So some materials do not break easily even if they are smashed onto the ground, beaten by a person, or stretched apart. These materials are described as strong. Materials that are not strong break easily when they are dropped, beaten, or stretched. Okay? So let me explain after you copy. Yeah, wait for rest. Okay. There are many things around us used for different materials. For example, sporting equipment. Whether it's paddle ball, tennis, table tennis, floorball, hockey, softball, baseball, all these use different equipment, correct? For example, table tennis, badminton, they use a racket. Floorball, hockey, they use a stick. Okay, baseball and softball, they use a bat. Can you imagine if every time we hit the ball or we hit the shuttlecock, our racket breaks? Can we have a game? Cannot, right? So when we say beaten by a person, person using it, we must choose a material that is strong enough for it. Okay, even a table tennis, even though a table tennis ball is basically plastic and air, we need to use the correct materials for a table tennis paddle. This morning I was watching a video of somebody who was trying to play baseball. You know what's baseball? The one where they throw the ball, then somebody use a bat and try to hit the ball. He tried to play baseball with a table tennis paddle. Have you seen a table tennis paddle? With a small racket. So when he tried to hit the ball was traveling so fast and the ball was so heavy that the pedal broke in his hand. The top part of it just crushed away. Okay? So that means that the pedal is not strong enough to play baseball with. So in this sense lah. So certain things also that are not strong. For example, your pencil. A normal pencil is made of wood, correct? In the middle there's a lead. Have you ever had the one where you sharpen your pencil and then you notice the lead break? Then you sharpen some more and then you see it's still broken. Have you ever had that? Do you know why? Do you know why the lead broke? It's not because you are sharpening it. It's because you dropped the pencil before. Now, when you drop the pencil, what happened to the lead inside is that it actually breaks apart. But you don't know that it's broken because it's covered in the wood, correct? So when you sharpen and you realize, hey, it's broken. Then you sharpen some more, hey, it's still broken. You sharpen some more, it's still broken. Because the lead inside is already broken. So that means if you use that kind of pencil, it's very important for you not to drop the pencil, even though the pencil is made of wood. Okay? So if we smash things onto the ground, we beat a person and stretch something apart, they do not break, then we say that that material is strong. In fact, most of the materials we have around us are very strong. However, there are some materials that we purposely choose to be weak. For example, what? Glass. Glass is hard one. What do you think? What do we choose to be weak? Okay, give you an example. The aluminum foil that your mother uses at home is easy to tear, correct? Why is it easy to tear? Because if it's hard to tear, can you use it to cover your food? Cannot, right? So we purposely make certain things weak so that we can use them. Okay? Understand? So this is the thing about strength. If it breaks easily, then it's not strong. If it breaks because we drop it, we beat it, or we stretch it, then it's not strong. If we are able to beat it, drop it, or stretch it, then it is considered strong. Certain materials such as rubber, if you pull a rubber band and you let go, it goes back to normal, right? That is not considered strength. The rubber band itself is strong because it won't break. But that is the next part, that is about flexibility. Okay? If you pull too much, it will break, but there are some rubber bands that even if you pull very, very far, it will not break. Okay? Any questions? Any questions? No? We will stop here because next week then we will go on to the other part, right? Then for Safia and AV, don't forget to do the checkpoint test at home. Alright, just time yourself 35 minutes and then try to finish the paper. Once you are done next week, I'll collect it from you. Okay? Pritika, any questions? No,